Okay, so I have my model cleaned up and ready to use. So you can see that I have deleted the objects that I don't need, and I have sorted everything into these layers that are the ones suggested right in the documentation that we just saw. So basically we have the foundation layer, and in this case you have noticed that I have added this basement level because this was actually part of the building, but it wasn't modeled in the original model, so you have to check out for that details that perhaps weren't important in the design phase, let's say, for the architects or other planners, but of course they are very relevant for the life cycle assessment. So check out if there are some parts of your building that you have to add to the 3D model. When we are dealing with a Rhino model with this plugin, I encourage to use either the wireframe or the ghosted mode, right? Because otherwise you are not going to see what's in your 3D model. So in this case, I'm in ghosted mode. In the lifecycle assessment, we have to consider also, let's say, the pavement or other coverings right above of these slabs. So for that reason, I have modeled these additional surfaces here on top of these volumes, and I have put them into the horizontal finish layer. Now you are going to see what happens when you get a 3D model that was not created specifically for a life cycle assessment, but if you were starting the design phase all over again, you might prefer to model everything, or at least the slabs, not as 3D objects, I mean, perhaps, but as surfaces, so that we can use just one surface both for the structure and for the horizontal finished objects, right? And finally, we have this final layer, floor area. These are these surfaces here. This is not going to be exported as a building material for the lifecycle assessment, but the purpose of this layer is to measure the building area in order to compute the results accurately, as we are going to see later on. We have our clean 3D model, so now we are ready to start our plugin for a One Click LCA, and we can locate it here, and we can start with our lifecycle assessment. Let's take a look into the structure of this plugin. So we can see that we have these 3 buttons on the top part, the help button, of course, that will take you to the documentation web file that we were taking a look at. Then we have the button LCA in cloud, which will allow us to export all our material quantities to the web interface of One Click LCA. And we have the refresh button in case we have to update the material quantities because we have modified our 3D model in any way. Then we have this space here for basically for results later on, so let's leave it like that. And we have this tab structure here. You want to go from the left tab to the right one. So let's start with the settings tab. Here, you basically choose the master database. In this case, I'm assuming that my building is in Germany, so I'm going to leave it as European data. Then you might want to log in, but the login is only necessary for 2 things. First, if you want to update the material database, right, in case that you want to use the latest one, and also in case that you want to get the results from the LCA back into Rhino. So let's leave it empty by now because we don't need to log in yet. Then we have the layers tab, and this tab is very interesting because we see that we have all the layers from our model here, and we have these 2 functionalities here. We can choose to include or to group the layer. So of course, if we include the layer, it means that we are going to map materials to the objects of that layer, and we are going to export them to One Click LCA later on. And in this case, I want to include all the layers, of course, because I have just cleaned up the model, excepting the floor area layer, because this layer, as I said, we are going to use them just to calculate the building area in a couple of minutes. So I want to include the other layers, and just let me ungroup the horizontal finish, the windows, and the door layers. This means if we group a layer, we are going to apply the same material or the same materials to all the objects. And if we ungroup them, we can choose to apply different materials to every individual object of that particular layer. And in the end, of course, you can check the number of objects that are included in this particular layer. and the total quantity of the objects of that area. So if all the objects are volumes, of course you are going to get it into cubic meters. If they are surfaces, you are going to get the square meters, and otherwise you would get the individual units, right, of elements. So this would be like a first check to see if your 3D model is what you are expecting. So this is the layers tab, and since we have made some changes here, we should click on refresh, because now we can jump into the next layer, materials, and here we can see basically all the layers that we are seeing before, and we can see just one entry for the layers that are grouped. But if we go to the, for example, to the door layer, we can see that we have one entry for each surface object of our model, because this layer is not grouped. So this is the tab that we are going to spend most of the time with later on. But yeah, just let's take a look into this structure here. And also it's very interesting that if you click into a particular layer, the objects of the Rhino model get automatically selected. So this would be internal walls, roof, and so on and so forth. And the other way, of course, if we click, for instance, this object here, we can see that our beam layer gets automatically selected. This is, of course, in my opinion, a very interesting functionality to map our materials in a more comprehensive way. So let's leave it like that. And finally, we have the results tab that is going to become important when we want to import the results of the LCA back into Rhino. So let's leave it like that. And now let's try to map the materials to our 3D objects. So for that, we have to come to the materials tab. So to sum up, we have two possibilities here. We can either use a database from the country where your project is located, or we can use more generic databases with more materials probably, but then you have to activate this material localization method in One Click LCA. If we come to the web interface of One Click LCA again and to our project, if we come to the parameters and the LCA parameters, there is a very interesting option here, which is material manufacturing localization method. If you activate this option, like I've just done, this means that if you are using a material from another country, right, different from your product, then One Click LCA will automatically adjust this data as if that material had been produced on the same country as your building is located. I'm going to go for the second option in this case, just so more viewers can relate to my materials, right? And let's start, for instance, with the external walls. In this case, they are just massive concrete elements, so we have to choose a concrete element for that. So if we click on the drop-down menu, we can see that there are many options to choose from, but few of them are concrete materials, right? And the thing is that, as we saw, there are more than 100,000 materials on the database, and this drop-down menu is just showing 100 of them. But if we want to narrow down the search, of course, we have two possibilities. We can either use the filters here, or just type in a search keyword, right, as we're doing in the web interface. In this case, let's use the filters. So for the external walls, let's scroll down until ready-mix concrete for external walls and floors. And I click on external walls, I can see which elements I have selected in my 3D model. And let's add concrete, in this case with concrete quality C3037. There we go. And of course, the nice thing is that the material quantity is automatically computed from our 3D model, right? So this step is automatically done. So first, it's faster, right? As if we have to do it manually. And second, it's more reliable because we are taking it automatically from the 3D model and we are seeing which elements we have selected, right? So I think it can be better. So of course, this is just the concrete, and since these elements are made up of reinforced concrete, it means that we still need to add our steel reinforcement material. But how can I add two materials to the same elements here? So for that, you just have to click into this plus symbol, And then you can add more materials. In this case, let's add a steel reinforcement material. So we have to change the subcategory filter. Let's set it to reinforcement for concrete. There we go. And there we go. So, but of course, and this is not cubic meters anymore. So this is kilos. And now, of course, we cannot automatically get the amount of kilos from this 3D model because the steel reinforcement is not modeled in 3D. So we have to input this quantity manually. So let's assume that we have here, I don't know, like 5,000 kilos. So we can assume if we are in the, of course, if we are at the end of the detailed design phase, we know exactly the amount of steel in our model. But if we are in the conceptual design phase, we have to make some assumptions. And for the walls, an educated guess would be that the steel reinforcement is about 140 kilos per cubic meter. So we just need to multiply 51 by 140, and we come up with 7,000, more or less, 7,000 and 140 kilos of reinforcement, steel reinforcement, right? And we're going to see how we can do this automatically in Grasshopper, right? These operations, but in Rhino we have to type in this quantity manually. And you can see that it has been highlighted in a blue color. That means that this quantity was not automatically computed from our 3D model, but the user provided it within a manual approach, of course. You can also edit these volume quantities as well, but of course these are right, so let's leave them like that. Okay, so that could be it for my external walls, because in this project there is no any kind of isolation. If you take a look into the pictures of the Asuma house on internet, you can see that this is a massive reinforcement, reinforced concrete. So now let's move on to the foundation, for instance, right, which are these elements here. And since this is also concrete, we can either do the same thing here or another approach, right, in order to make assumptions into this in these early design states could be, besides to assume a ratio for the steel reinforcement, could be to use the so-called constructions or assemblies of the database of One Click LCA. So for that, we just have to click into assembly. Let's, in this case, let's unselect this filter here, and let's type in this case, foundation, and let's see what we have here. We have concrete slab foundation inclusive reinforcing per cubic meter of a slab C3545. So an assembly is basically an element that is made up of several materials. And not only that, they also assume a certain density for the steel reinforcement. So if you trust the database of One Click LCA, these materials are perfect for the early design stages, right? Because they made the assumptions for you, and you have to select just one of them instead of several materials. And of course, later on, when we export all the data to One Click LCA, we can edit these the individual material quantities of this assembly if we disagree with any of these assumptions. So let's leave it like that. And now I will move on to fill in the quantities for the internal wall, slab, roof, beam, and stairs. But yeah, this is basically reinforced concrete, so the process is pretty similar to what we have just done here. And then I also did the internal walls. For the slab, I've used a construction, right, an assembly, which includes the concrete and the steel reinforcement as well. Then I also mapped the roof, the beam as another construction, and the stairs. And by the way, we said that for walls, it's an educated guess to assume a ratio of 140 kilos of steel reinforcement per cubic meter of concrete, and for slabs, 110 kilos per cubic meter of concrete would be also a reasonable figure to assume here. Okay, so I'm done with these elements here. And by the way, feel free to save the model and go on later if you want, because as I said, these material mappings are going to be saved along with the Rhino model. So you don't have to do anything when you open the Rhino model again. These mappings are going to still be here, right? So we are basically going to go just one by one. So let's start with this exterior door. So I'm going to use an assembly, and just let's type in door, and we can see that one of the options is external door. At this moment, I mean, this is an assembly that is made up of several materials, as I already said, but at this point, you don't have to worry whether these are, let's say, sustainable materials or not. We're going to review all the materials later on the web interface, right, of One Click LCA. So that was my external door. Let's move on. In this case, let's deselect assemblies, and let's go for aluminum framed glass doors, right? And let's select, for instance, this one, mixed aluminum, PVC, framed windows, and patio doors. It seems like it makes sense. And now let's go with the other one. So with the other one, we just can copy the material for that door and paste it here, and we then select it. And now this is an interior door, but this is another glass door, so let's paste it again and then select it. We have to select it because otherwise we're just typing in text. We haven't actually selected any material. And now that could be the other patio door, so let's do exactly the same. And I think that we have just these interior doors left. So let's unselect this filter here, and let's select assemblies again, and we have to type in door, and now we are going to select the interior door material, just like that. And okay, so it seems like we are done with the interior door, so we can, for instance, save the model again and move on to the windows. Let's use that unit here, and I'm taking a look, of course, to the objects that are selected in Rhino, and just like that. And now we are actually we still these two here, and there we go. So we have from 1 to 6, and 1, 2, 3, 4, 5, 6. So now let's move on to the other windows, and these are just normal windows. Let's select assembly, and we can type in window here. Let's see which kind of assemblies we have to choose from. So let's go, for instance, with double glazed window inclusive aluminum frame. So that makes sense. Let's copy the whole material, and let's paste it for the other elements, right? And now we are done with the doors and the windows. Okay, so let's move on to the horizontal finish layer, and remember that this layer refers to all the elements that are on top of our reinforced concrete slabs. And for this process, it is very important to have a reference section, right, to take the materials from. So in this case, I'm going to start with the standard floors in the ground level. And let's assume that this is the section that I have to replicate in my LCA model, right? So we have the, I'm sorry that it's in German, but I hope it's clear enough. So we have the concrete slab, and then we have, of course, the insulation layer, and then this membrane, and then the mortar screed, right? A very typical floor structure. So let's try to map these materials. So, and this could be the horizontal finish object 5. We can see that it's selected here, and 4, right? Okay, so let's start with the insulation material in rock wool insulation. That's right. And now we have many different material to choose from. Let's select this one, for instance, and again, I said that we are going to review the materials later on in the web interface to see their impacts, if they make sense, or how they compare with the other materials. But also, it's very important that anyway, the selected materials are by the moment generic materials, right? Because these generic materials, that means that they don't come for any particular manufacturer, but they are, let's say, an average of the impacts of similar materials. So later on, when the construction phase comes, if you want, you can repeat the life cycle assessment if that's required with the more particular specifications of the materials that have been actually purchased. And then those values should be similar to these generic materials, right? But again, in these conceptual design phases, it is very important to stick to generic materials unless, of course, there is no generic material available for our requirement. But in this case, there is. So let's move on. Okay, so that could be the insulation material. And now let's add, of course, more materials now for this membrane, of course. So let's try to search it. Sorry, of course, but I have to unselect this filter here. And for this one, okay, so we have our insulation material, our membrane, and now we need, of course, the screed material. So let's add one more material, and of course, if you want to delete some of the materials from our particular construction, you can remove them by clicking on the minus symbol. But now let's select the screed material, and we need a mortar screed material. Yeah, okay. So there you go. But we have selected our materials, and of course this comes in a square meter because we modeled a surface element in Rhino. But now you can see that we have to specify the thickness for the first time, right, in our model. So there are two possibilities with the thickness because we have already selected other surface elements, but there are two possibilities: that the thickness is not available because it is already defined by 1 Click LCA. It can also be possible that the thickness is fixed, but we can already see it. Or it can be possible that 1 Click LCA specifies a default thickness that we might edit, of course, if that doesn't correspond to our particular building. So in this case, the rack insulation, this 100 is a default thickness, and we are going to assume 50 millimeters. Yeah, if we leave the cursor here, it says a thickness in millimeters, right? So let's assume 50 as well for the screed material, and we can see that we can't specify any kind of thickness for the membrane. It's fixed by 1 Click LCA, and that's very interesting because, of course, it could be very difficult to figure out the thickness of this kind of polyethylene membrane, and it's a very good thing, in my opinion, that 1 Click LCA also specifies these values, so you don't have to do it. Okay, so that was this horizontal finish here. Let's go to the other one, just on the other side of the building, and let's just copy this material. So that could be my insulation layer, and with the screed material. Okay, there you go, and of course the thickness. So that could be it. And now we can move on to the roof, I guess. This is the section for our roof. So we have insulation material again, we have another membrane, but in this case it has to prevent humidity to come in, so we have to choose another material. Then we have this kind of gravel or ground material, and of course my floor tiles. So yeah, we can select the same insulation material. There you go, thickness 50 as well, or we can even do 100 here because of course this is the roof, everything according to our section. And then we need our membrane. We are going to assume that we have yeah, bitumen sheets. That makes sense. And you see, if I select this other material, but now outside of the generic material, it's possible to get square meters. If I stick to generic materials, in this case, I had to select kilos. So okay, since this is not a very relevant material, I'm going to go for this option, even though it's not a generic material, right? So let's assume 20 millimeters, and that should be it. Okay, so you get more or less the process, and now I'm going to just fill in the rest of materials for my horizontal finishes.